All right, so sorry, my last video, I accidentally stopped it instead of paused it, so I have to make two halves to my video. Okay, so we left off here. You guys were doing this first paragraph here, and I did this with you. I got the layers together with the boundaries, which are the pauses, right? And the pauses, what they are is when you think about, and you guys have probably already read all of this, so we're looking at the temperature changes, right? So what's gonna happen here is as we read through this, we read about Earth's surface being the primary absorber of solar energy, and it's re-radiated by the Earth as heat. So right next to the ground, right, it's the warmest place because of that. That's where we get the most absorption, but at the same time, the Earth's surface releases heat there. So if you think about it as a frying pan, if we heat up a frying pan, right, and then you kind of hover your hand over top of the frying pan, you can feel the heat coming off the frying pan without actually touching it, right? So that's the zone that we live in, and that's for a good thing, right? But then as you take your hand further and further away from that frying pan, you feel less and less of that heat being dissipated, right? And so what happens in the troposphere, right, the layer that we live in, this is the temperature gets less and less. So it gets cooler and cooler and cooler as you go up in your airplane, right? But then as we hit the tropopause, the temperature actually pauses, right? So that means as I go up in altitude, my temperature stays the same. It doesn't get cooler, it doesn't get warmer, my temperature stays the same. So that's why we call that the tropopause, because the temperature pauses. And then once we enter the stratosphere, okay, the stratosphere begins to warm back up. Okay, and so down here it starts talking about Earth's biggest. Okay, so essentially I gave you these two bullet points down here. This one was talking about the troposphere. It was talking about the solar energy is absorbed as it moves through the layers, and then the biggest absorber is the Earth's surface, and then it also releases that heat. So then that's why we get the troposphere as the warmest one. But then it cools as we go up through the troposphere. And then this next one starts talking about down here, it starts talking about the stratosphere. So the stratosphere begins to warm with the altitude. So as we go up in altitude, our stratosphere warms. Why does it warm? Well, if you look right here, it says this warming is caused by a form of oxygen called ozone, which is O3. Thanks again. So we have this odd molecule that absorbs ultraviolet radiation from the sun. Ozone protects us from the sun's ultraviolet radiation. So this is a good zone. Like, we need this. Actually, so it starts talking about down here. Scientists are concerned that human activity are contributing to the decrease in stratospheric ozone. Nitric acid, or oxide, which is exhaust of high-flying jets, and chlorofluorocarbon CFCs, which are caused by refrigerants, may contribute to ozone depletion. So this used to be a big deal back in like the late 90s, early 2000s. We were starting to see some like satellite images of our poles warming up really fast because of that ozone depletion. Well, since then, we've made laws to get rid of these chlorofluorocarbons. We still have high-flying jets. I don't know if they changed anything. Their jet fuel, probably not. But anyways, what we have seen, and now that we're here in year 2021, these ozone layers, these holes at the poles, at the North and the South Pole, where we think the ozone layer was depleting, they've actually filled in. So ozone kind of it regenerates itself. So that's a good thing, right? It kind of healed itself. We need that ultraviolet radiation we need to be protected from that ultraviolet radiation, because that UV rays, those are the things that give us our sunburns. And so if that intensity went up, then we'd get sunburnt easier. We would have a higher rate of skin cancers and things like that. It would hurt all life, not just human lives with, getting a bad sunburn, but getting pounded with UV radiation, high intensity UV radiation for your entire life can lead to very big health concerns. So anyways, that's a lot of energy is what I'm getting at. Well, anyways, the ozone molecule absorbs that energy, and when you absorb energy, you warm up, right? So the ozone layer has been damaged from pollution. That's what I wrote here. Then finally, our last one, we talk about the mesosphere and the thermosphere. So the mesosphere doesn't absorb any solar radiation. So now we went from the troposphere, where we live, we went to the stratosphere, where the ozone layer is, and now we're at the mesosphere. So now we're cooling back down as we go up through the atmosphere. And this is because the mesosphere doesn't absorb any solar radiation. Well, as we get higher and higher and up into the atmosphere, the air gets thinner and thinner, right? If you guys ever went hiking in the mountains or anything like that, or if you tried to open up the door to an airplane, the pressure is decreased. Why? Because there's fewer gas particles up in the atmosphere. So if there's fewer gas particles, there's fewer things to absorb that solar radiation. Therefore, it's just not going to warm up. So it's cooler up there. And then at the end, it starts talking about in the thermosphere. So you think about heat, right? The temperature begins to increase again because the sun is hitting this layer directly. So the sun is baking this first layer, and it's getting really, really hot. However, it talks about you need special instruments to get a temperature reading on this, because when we think about a thermometer, right, we put thermometer into like a glass of water, and we have all these water molecules that are banging off this bulb of our thermometer. Well, there's no air particles up there, or there's very, very few air particles up in the thermosphere, but we know it's hot because we have these certain instruments that can measure the flow of energy through a certain point, which gives us then the temperature. So that's what it's talking about, a special instrument. Okay. So get on with your homework. So here, you guys have to do 1, 2, 3, and 4. And honestly, 2, 3, and 4, they're all the same thing. You're just labeling these layers of the atmosphere. And here's your word bank. And then number 3 is here's your ozone layer. Okay, so it's just what you're going to do is you're going to end up labeling this graph. Okay, and so what you're going to do here is this is all one table. So these two. And then it begins. So if I go, here's my altitude. So sea level's right here. So we got our sea level here. And then what's going on is once we start at sea level, we're going up 5 kilometers, 10 kilometers, 12, 20, 25, 30, 35, 40, 45, 48. And then we go to 52, 55, 60. Okay, so this is a table. This should be right down here, but we wanted to save some room on our page. Okay, so it just continues right up over here to 52, 55. And then as you're going up with altitude, make sure you're plotting the temperature at the same time. And a lot of these temperatures are in the negative ranges. Okay, so be careful with that as you're plotting this. So again, they change. It doesn't. So as you go through this graph, you might have an idea in your head that if I start here, I think your first one, here's ground level, right? So if we see, so altitude, so this is our y-axis. So this guy goes right here. So if we're talking about our altitude, here's sea level, right? And then here's 5 kilometers above sea level, 10 kilometers, 15, 20, 25, right? So on and so forth. Here's our temperature. This is our x-axis. And so our first one is 15 degrees Celsius at sea level, right? If I go back to my table, it says at 0 kilometers, we have 15 degrees Celsius. Is that right? So here at 0 kilometers, we're at 15 degrees Celsius. Okay, then the next one goes 5 kilometers. 5 kilometers, and I wish I had this in my head, and negative 18 degrees. Okay, so 5 kilometers and negative 18. So here's negative 10, negative 20. I know negative 18 is not quite halfway. It's a little over halfway. So I'll put it right here. Okay, and you guys can make these dots a little bigger, however big you want. Anyways, you guys are going to graph all of those all the way up here to 100 kilometers. So it's going to be, and then after that, you're going to connect the dots. Okay, so as you see the temperature changing, so this is going to curl up kind of like a snake. All right, it's not going to continually get colder and colder and colder and colder. It's going to change back at some point. So as it begins to change, right, that's what we were talking about here with these notes. As these temperatures change, as it gets warmer or cooler, you should know what atmosphere. You already know the layers. This is the order the layers go in, so you should already know this. But now you're paying attention to, as the temperature changes, where does a certain sphere begin and where does a certain sphere end? Where does a tropopause, or where does one of those pauses end to begin? Sorry. So again, don't forget, you will. That's what this part is. Whoa, sorry. So on your graph, my mouse, that's not me, I promise. My mouse is not doing well. Okay. This is your word bank. You got to use all of these guys. And then over here, you're just answering questions. So does the temperature increase or decrease with altitude in the troposphere, stratosphere, mesosphere, thermosphere? So you can read all of this stuff, or you can look at your graph. You can read all of this stuff here. You can look at your graph. Okay. You can use both. I would suggest using both. But that's all I got for you today. Okay. Bye.